So here we're tasked with finding the volume of a parallelepiped that is defined by the three vectors that are presented to us. So to stay consistent with what we had laid out in the previous video, we're going to say we're going to find V cross W, and then we're going to take the dot product of that with the third vector U. So we've got to work here first. We have to find what the components of that cross product are. And then we're going to take the components of that cross product and do the dot product of that resulting vector with the vector u. So if you'll recall from our previous study, we've got our method of determinants that we can use to find this cross product. So I'm going to run ijk across the top, and then I'm going to run v, so 2, 2, and -1, and then w, -4, 3, and 2 across the bottom. And then I'm going to use that method of determinants. So I eliminate the first row, and then create the 2 by 2 matrix and go from there. So in order to not clutter up our diagram, I'm going to stay away from those lines and just remember that I've got 2 times 2 minus 3 times -1 times I. Then I'm going to subtract. It's a key element of this. I'm going to subtract. I'm going to eliminate the top row, and now the middle column in the 2 by 2 matrix I'm left with is 2 times 2 again, minus -4 times -1, j. And then lastly, eliminate the top row and the last column. So I'm going to be plus 2 times 3 minus -4 times 2 k. So now I'm going to perform those operations. I'm going to multiply, do my subtraction, resolve all of my arithmetic here, and so we eventually end up with 7i minus or plus, depending on what your preference is, 0j, and then plus 14k. So this is our cross product of u and v. And so now I'm going to take the dot product of that vector with u. So I've got 7i plus 0j plus 14k. I've got my vector u, 3i minus 2j plus 5k. And now I'm just going to multiply the components and corresponding components and add them. So 7 times 3 is 21, plus 0 times -2 is 0, plus 14 times 5 is 70. So I end up with 91 as my answer, and so that is 91 cubic units or cubic inches, whatever units we're operating with, is going to be the volume of a parallelepiped that's defined by those three vectors. And the nice thing is, it does not matter if we decided to do u cross v and then take the dot product of that with w, or u cross w and then cross dot product of that with v. We're going to end up with the same answer no matter what. Now, one thing we can do to speed things along, instead of having to separately find the cross product of the first two vectors and then multiply times do the dot product times the third vector, so we can go ahead and do everything in one determinant calculation. So if you'll notice here, I've got the bottom two rows are the same as the matrix that we used before. I've got the vectors v and w, but now instead of having I, j, and k across the top, I've got my vector u. So we've got u across the top and then v and w in the next two rows. And so if I go ahead and just do find the determinant of this 3 by 3 matrix directly, that's going to be the triple scalar product. And if we think about why that works, if I eliminate this row and this column, the number I have here is 3. So again, I'm going to erase that just so that we don't get distracted. So the first part here is the same as what we did before, 2 times 2 minus 3 times -1. So that's going to give me the I component of my cross product vector. And so then instead of multiplying that by I, I'm just ending up immediately multiplying it by the x component, the I component of my u vector, the one that I'm eventually going to take the dot product of, and then I'm going to be in business. Now, I'm still finding a determinant, so I still need this minus sign. So I'm going to, again, eliminate the top row and the middle column. So if we undo that work there, I've got negative 2 is hidden, so I've got 2 times 2 minus negative 4 times negative 1, and then that's being multiplied by that negative 2. And then finally plus, I'm going to eliminate the last column with that top row, so we're going to have that 2 times 3 minus negative 4 times 2, and then that's going to multiply this 5 that's up here. And so once again, we're ending up with 7 times 3 minus 0 times negative 2 plus 14 times 5. Hopefully all of that looks familiar from our previous exercise. And so we get 21 minus or plus 0 plus 70. We end up with our same result that we did before. So this just shortcuts it. So instead of having to do it in 2 separate steps, find the cross product and then perform the dot product with the third vector, throw all 3 vectors in any sequence in your 3x3 matrix, find the determinant, and you've got your volume. The one thing I'll add on, sometimes we'll get a negative answer for this determinant. It just depends on this order in which we use the vectors. So of course we know volume can't be negative, so we just have to take the absolute value of whatever answer we got. So there's no need to panic if you get a negative answer, you didn't do something wrong. It's just the nature of this. We just have to take the absolute value of whatever our result is, since volume can never be negative.